would be more than happy to. Konnichiwa. Or do I say Ohio gozaimasu? My Japanese is terrible, but I'm so honored to be here with you. Thank you so much for hosting RISC-V Days Tokyo. I only wish we didn't have this pandemic, that I could be there with you in person. I so much enjoyed my last time in Tokyo with you, and I look forward to joining you again in person, perhaps next year or this fall. Are you able to see my charts, my presentation? I can start there. Wonderful, thank you. So I'm going to share with you a bit today about the progress and the path and the journey that we have been on together. I want to first just start with a recognition, an acknowledgement that the world has so many challenges. We have technical challenges, we have civilization challenges, societal challenges, and time and again, we find that collaboration, coming together to tackle those challenges, to solve the most difficult problems, comes together for the long, durable future when we do it as one, when we come together globally. We come together locally, regionally, by country, as well as globally. And open source is a catalyst to moving forward as an industry and as a society. So it is an honor to drive together with you RISC-V as sort of the power that is compelling the changing computing for the foreseeable future. So this is our time. But why is this our time? We must really look at why is this the right time in history for us to seize these growing opportunities in RISC-V. Really, it comes down to the market. The market is going wild for new types of computation, new custom processors, growing exponentially where there weren't processors before. This is not growth of existing workloads. This is primarily growth of new workloads. And RISC-V is in the right place to really help with that unprecedented demand. So that demand is coming from IoT, from embedded, from industrial, from automotive, from data centers, from cloud and hyperscale that are looking to add new capabilities into data centers that power the world. We are looking at RISC-V projections by the analyst community here. In IoT, nearly a third of the market will be on RISC-V. Automotive is projected to be just in a few years from now, 10% of that market will be on RISC-V. This is an amazing opportunity. So the business construct is there, but what does that say for where we are today? The future looks bright, and today we're already seeing that transpire. So already nearly a quarter of ASIC and FPGA projects are already including RISC-V in at least one processor. So this is something that we predicted, and it's happening already. This is where RISC-V really comes into play. RISC-V is free and open. It's a very simple and modular architecture. It's allowing the types of collaboration that have never been seen before in hardware. And this is for two basic large reasons. On the technology side, it's very simple. We've truly taken a modular approach. You have a very small base and you add on to that just what you need, rather than take an entire instruction set that has been built and added on to for decades. This is also paired together with complete design freedom. Not only can you take that simple base ISA and add on to what you wish, but you have complete freedom to continue building and going in new directions. You're not limited by your investments, by your engineers. In fact, collaboration to meet those new demands is really where you find amazing opportunity. The second area is around the business opportunities. So there really is no limit. There are no licensing fees associated with the open pieces. You are free to take the open building blocks and bring your differentiation on top of and around that. Take it to market and be commercially successful. That removes the limitations, removes the barriers so that anyone can participate. We now see more startups in RISC-V than any other architecture in history. This is important. This means that anyone could go after that opportunity, which also means that your number of partners has expanded exponentially. Your supply chain continues to grow. The number of engineers that are deep in RISC-V knowledge has continued to grow exponentially. This also means that if you're a stakeholder who is depending on a single supplier, you can broaden that. You don't have lock-in. There's no risk of that. And the technology is collaboratively owned by everyone. It is freely available to everyone, and everyone is investing in it. That means it is a shared investment. We are all relying on it. We are all investing in it. Very similar to what we saw in Linux. Linux is also a shared asset invested by millions and used by millions. It's the upstream, downstream, and collaboration effect of open source. So we've had different estimates on how many cores are actually in market today. Our initial estimates were somewhere around 2 billion RISC-V cores in market in 2021. We've revised those estimates a couple of times. We now believe there's more than 10 billion RISC-V cores in market. Those estimates need to be refined because when you are open and available to anyone for license, it's very difficult to go back and count that or audit that in any meaningful way. So we're working with the analyst community to try and get a very tight handle on how many cores are in market today. So we'll use more of that information in the future. But the analysts are very positive on RISC-V. In fact, Deloitte says that where we are in 2021 will double in 2022 and double again in 2023. That is matching with our projections and what we see happening in the community. This has already taken off in 2022. We started the year very strong with the European Commission announcing their European Chips Act of 15 billion in additional public and private investments. This is really important because they are specifying RISC-V, and this is freeing up billions of dollars in public investment into RISC-V as well as the surrounding ecosystem. We're seeing this in other countries as well. In fact, in India, we just saw a massive investment take place as they joined the board of directors in RISC-V. So we're seeing it at a public level with countries and governments. We're seeing it at a commercial level. So in the multinationals, we saw Intel make a massive investment and declaration of support for RISC-V. This reminds me of Linux as well. So back in 2021, or I'm not 2021, 2001, 21 years ago, a company called IBM said, you know what? We want to have our own software and we want to invest in open source. Open source is the future, and open source is where we need to come together and collaborate. There will still be room for our own business, but we want to collaborate as well. And they declared in 2001 $1 billion investment in Linux. This is our Linux. RISC-V is the Linux of hardware. And as you heard, Intel said, here's $1 billion. We're putting it on RISC-V to help the surrounding ecosystem and help foster the success of RISC-V in the industry. And they are true to their word. In fact, I've seen them in Europe. I've seen them very active in China. I've seen them around the world, including North America, seeking to help support the RISC-V community. And so this is very important to us. At the other end of the spectrum, the startups, small companies that began their destiny on RISC-V, such as Sci-Fi, gaining a $2.5 billion valuation. This is a company that didn't exist a few years ago. this is the kind of traction that is happening in the RISC-V community, and it's really profound. And so many more stories like that are already coming out each and every day. So where are we seeing RISC-V? Well, in the data center, we see Esperanto coming out with 1,000-core RISC-V accelerators. In fact, Dave Ditzel, one of the original founders around RISC, has declared his support and joined Esperanto as part of this mission. Alibaba, a great supporter of RISC-V and a strong open source citizen as well, has open sourced the Wanshi processors and looked at where they are in their development time frame to bringing RISC-V into the data center. Seagate and Western Digital, both very strong on RISC-V for storage, essential piece of the puzzle. And even Intel has a RISC-V based processor. So we're seeing this a lot. And there are a couple of companies, new companies, Ventana and Rivos, who have also made amazing strides in the data center. And we hear about things going on all the time, from hyperscales to data centers to system providers and others who are participating in this extremely fast growing space. In fact, this one's projected to be one of the fastest growth ones, 115% CAGR. That's incredible growth and incredible opportunity. We're also seeing incredible progress happening in telecom and communications. So Realtek in China is already using RISC-V for Wi-Fi and Bluetooth capabilities. Alibaba has helped us to port Android 12 over to RISC-V. And Andes has also been working with SK Telecom for AI products. Google is participating with the Pixel 6 Titan M2 RISC-V processor. And we hear from around the world and across industries the importance that 5G and other wireless capabilities are converging in telecom as well as IoT. So we're continuing to see this grow very, very rapidly. Automotive, an area that is very core to Japan as well. We've seen great advances from Intel's Mobileye unit. They have already achieved some incredible benchmarks in driver assist systems. Andes is working on many different products around functional safety and getting the ISO certifications as well as things like power converters and better battery charging efficiency from the Europe GA Next project. So your automotive is growing very fast, but from a smaller base. There's a huge opportunity here, and we're seeing this transpire from many different companies and collaborations, including Renesas, NSI Texi, and others who are very active in this space. And almost every one of these stories that I'm hearing is a collaboration between different stakeholders in the RISC-V community. That's powerful. That's lasting and durable. In consumer and IoT, Huawei has a Harmony OS board available already. And we've seen the Huami wearables from now named Zepp Health happening for several years now. GreenWaves has its own GAP9 hearables platform, which has been wildly successful. In fact, there are millions of RISC-V earbuds coming out from China every single month. And these are things that are continuing to build the momentum and the interest in RISC-V. AI and ML continue to be a very fast-growing area with projected $291 billion in revenue by 2027. This is a huge market, and there's room for amazing levels of participation. So I would point to these areas as we add AI from data centers to automotive to IoT and everywhere in between. AI is something that is bringing a competitive differentiation to many different compute workloads. And AI and acceleration are a couple of areas that we hear a lot as fantastic opportunities for a RISC-V implementation. We continue to see a lot of collaboration here, as well as in edge computing. So, Fraunhofer ported their TensorFlow Lite to RISC-V processor core, especially for edge AI applications. Micromagic, very fast, 64-bit RISC-V core with incredible performance. Western Digital and Microchip continuing to bring development kits and storage capabilities to the edge. High performance computing. The ISC conference is going on as we speak. And so we're hearing a lot of great RISC-V stories, including the Italian company E4 in collaboration with universities like ETH Zurich and others on the Monte Simone cluster. And this is together with Unibo. And so these are examples of, cluster implementations for RISC-V coming into high performance computing, which, by the way, is the same type of scale out workloads that we see in data centers. And each one is continuing to strive for that performance, that power efficiency, that code density that will help to provide them with that leading edge in that workload. In the Technical University of Munich, too, this image here is around quantum cryptography and reverse engineering things to, plant Trojans and find opportunities to strengthen the security of RISC-V. Security of RISC-V really starts with transparency, and it doesn't get more transparent than open source or open code. You can see everything, and we are ensuring that utmost level of security and reliability across all of the things that we do. So you continue to see this. Tactical Computing Labs is very engaged in this as well. And our HPC work groups are some days having the most fun of all. I mean, they honestly are running after all kinds of new workloads, and it's exciting space to be in. None of us work in isolation. It takes an entire community. And that community must collaborate and work together with other groups and other organizations. That's something that you see here as we look at our ecosystem. All of the things on this page are available and ready to go on RISC-V today. When folks look at RISC-V and wonder where are they at in the ecosystem, it's very easy for us to see. This chart is growing very rapidly. Pretty soon the logos are going to get way too small. But this is a testament to the importance that the community is placing on RISC-V and the rapid and deep investment being placed on the entire ecosystem. So whether it's the stack, as you see in the middle, or the services that must be found across the entire implementation, the architecture test to ensure compatibility to the base ISA and maintaining that that is intact all the way through to tape out and into production. It's ensuring that we have a golden model, the SAIL golden model, which is something that you see here, as well as the tools, testing, and other things necessary to get that design right. So there are a lot of areas that we are working on and collaborating on, but it is important to note that we are engaged across the entire ecosystem. RISC-V has continued to grow very rapidly. In 2021, we had almost a repeat of the year before, 134% growth in 2021. We are now more than 2,700 members across 70 different countries. We continue to be about 1/3 North America, 1/3 Europe, and 1/3 APAC, with a bunch of that in China, but a very strong and growing set of that in other parts of Asia. So we see a lot of different institutions. We see commercial interests, we see academic interest, and we see all sizes and shapes. So it's a rich community where everyone has a role to play. If you haven't joined RISC-V already, I hope you'll reach out to us because it is an incredible community to be a part of. These are the 6 programs that we offer to help support the success of our members. We are a nonprofit. we don't make, a profit. We're here to serve your success. And to do that, we ensure the technical strategy is in place and moving forward with great fruition. We ensure that you can make something that is compatible to the base ISA. We strive to make all of the success of our RISC-V community incredibly visible. We are building learning and talent for universities, online learning, and group curriculum with training partners. We have an incredible global dozens of ambassadors and local meetup groups around the world, as well as enacting alliances. We have a couple dozen alliances with other strategic organizations to help support all of this growth. And then marketplace exchange. This is an area where we consider to be the center of gravity for the various cores or tools or software, anything you need for your implementation. We've got a lot to do, and we're not slowing down. This is a peek at our development roadmap. I know it's a bit of an eye chart, and it's probably way too small on everyone's screen, but there is a lot of work in progress. We have 66 different work groups very active today to make sure that we maintain our step in not just the base ISA, but a menu of additional building blocks to help bring your implementation to life. Contributing to open source and contributing to a community like RISC-V is a benefit to you. Asking your organization to sponsor your participation or to say, hey, you know what, spend half of your job on this, on RISC-V. Devote your role, your team to RISC-V. And studies are showing that this really pays off. For every dollar you put in, you'll get 4 back. That's a recent research report that came out in Europe. You'll find technical advantage. You'll have a faster development cycle. The training of your engineers will happen because they're working shoulder to shoulder with their peers. They're domain experts. And that resonates with talent. We see higher levels of retention in teams that are participating in open source communities. We see the opportunity to attract new talent to your organization because they appreciate the values you place on open collaboration. So I encourage you to think about, the many ways that you can bring RISC-V into your corporate strategy, into your academic strategy, into your government strategy. Where can you infuse and support and build and grow your RISC-V strategy as it relates to the many stakeholders and the many organizations that you have? So thank you again. I appreciate the time with you today. I'm happy to field any questions, although I'm not sure how any of those questions will come through. But most of all, engage, step forward, find yourself at home in RISC-V. Join us on social media. We have, great leadership locally in Japan where you can connect with your peers and other companies that are active and engaged in RISC-V. Connect with me, reach out to me. Let me know how we can best support your growth and ambitions. And we'd be more than happy to do so. So I'll close there and welcome any comments or any other questions.
So I'm interested in some example of collaboration between the RISC-V International and some open source activity. So I heard that some Linux open source activity is already collaborating with RISC-V International. Do you have some good example to tell us about the activity about such a collaboration? Will you show
recently,
some? Yeah.
So, recently we actually had several pieces of code accepted into the Linux kernel in accepting to in support of RISC-V. So they've made all of these updates in concert with updates for x86 and ARM, and they have now been bringing in updates for RISC-V specifically as well. On this chart, you see a lot of different examples. So, Linux would be the penguin there on the operating systems line. We actually work with each of the Linux OSs, with Red Hat, SUSE, Canonical. So we work with all of those. We also are, very active with KVM, as well as many others. Especially in the open source community, there's a ton of support. And the RTOS, you see Zephyr is one also, and are very supportive, mutual supportive in the community. And so you do find a lot of the community is interested in open hardware building blocks as well as open software. And then, the model is sort of that you can also bring and commit open source versions of things and then be able to glue onto that later for something that brings your differentiation to that product or offering as well.
Question is, are there any technical advantages to RISC-V other than the wider ecosystem?
The technical advantages that we most often point to are the flexibility and the no design constraints, right? So when you start with a very large code base like traditional architectures, 1,500 instructions versus 47, that's a huge difference. It's much more complex. You have much tighter control from a technical angle with RISC-V than you do on a proprietary one. The design freedom is also incredible. You don't have to go and negotiate a license to go get started on your implementation. Those negotiations can take 1 to 2 years, depending on where you're starting from. And so having that technical capability is very important. Many have also really appreciated the full transparency and ability to have full visibility for security reasons throughout the code, as well as other nuances. So some are looking, have looked at RISC-V from the beginning as an option where you can enact something for low power. So when you make a design choice, an architecture choice, you have price, performance, and now I think the next variable is design flexibility. Sometimes, the constraints that your design must meet include power consumption, include other, code size limitations or physical constraints or physical environments. That's very important as we look at things like aerospace and automotive. As we get into autonomous driving and other safety critical applications. So these are things where having that full flexibility and transparency becomes incredibly important.
Then, I have another question to you. So you showed about some actual example of which some companies is doing something with RISC-V project or so. So then I have one thing about the HPC. And so how about quantum computing in the RISC-V activity? Do you have some good example for quantum computing with RISC-V also?
I don't have something on quantum computing. The example here was quantum cryptography. So we are moving into that realm, but I don't have a living example of that at the moment. Perhaps there's one out there that someone will now raise a hand and tell me.
Okay. Oh, sorry. Thank you. Thank you for the comment. So, then now.
We're almost there.
Yeah.
Yes.
Oh. Okay. So it's in the future, maybe it's good going to be some high technical things, example, computing. So thank you so much. It's time to move to next. So yeah, your presentation is very, very effective and grateful. So thank you for taking time to do such a presentation. So then we will next the program. So thank you.
Thank you so much. It's an honor to be here with you. Enjoy the rest of the conference.